Hello guys, this is Saurav Kumar. Welcome to my new YouTube channel, Day with Science and Technology. Today I will be explaining video on Codeforces contest.
Codeforces Round 900 Div 3. Problem A. How much does Daytona cost? So I am going to open the problem statement for the question. So we define an integer to be the most common on a subsegment if its number of occurrences on that subsegment is larger than the number of occurrences of any other integer in that subsegment. A subsegment of an array is a consecutive segment of elements in the array A. Given an array A of size n and an integer k, determine if there exists a non-empty subsegment of A where k is the most common element. So here, like the test cases is given, the range of test t is given from 1 to 1000, and the range of n is given from 1 to 100, k is also 1 to 100, and the array's value is from 1 to 100. So basically, I will be explaining you first what does this question says. So here, as you can see, so here in this question, uh, let me take the first test case, which is this. So this is the test case 5 4. Okay. So the the size of the array in this given test case is 5, and the value of k is 4. We need to find there exists a subarray such that 4 exists that subarray more than any other element. So as you can see, we can find many such subarrays. So let me explain you with the help of pen. So we are given this array of size 5. So sorry for the bad handwriting. So this is the array. So we need to find if there exists a subarray in this array such that 4 the number of occurrences of 4 in that subarray is more than that of any other element in that subarray. So I can show you that there exists many such subarray which contains the element 4. For example, this subarray, if you take this, then this will not be that subarray such that the 4 uh, 4 occurs more than any other element, because here in this subarray from 0 to 1, we can see that 4 occurs one time and 1 occurs one time. So the number of occurrences are equal, but we need to find the number of occurrences of 4 occurring more than the number of occurrences of 1 occurring. So this will not be counted if we take this like this. So as you can see that here the number of occurrences of 4 is 2, and the number of occurrences of like any other element which is only 3 is only 1. So here you can say that yes, it is uh, like possible uh, to find a subarray such that the number of occurrences of k, which is 3 in this case, is more than the number of occurrences of any other element in the array. In this case, the element other than k, which is 4, is 3. So the number of occurrences in this subarray from 2 to 3 indices is uh, 1, and the number of occurrences of 4 is 3. So like how to uh, like let me give you some other example. This was test case 1. let me show you another test case. uh, Test case number 2. So suppose, so this is the test case number 2. So here, let me draw the array with a pen. So the size is 4, 2, 3, 4, 4. So here we have to find like if there is any subarray such that the number of occurrences of one in that subarray is more than the number of occurrences of any other element. As we can see in this array, there is no such element as one, so the answer will be no in this case. So, like, how to approach this problem? So there can be like uh, multiple approach to this question. First, let me show you the brute force approach. Uh, so in the brute force, what we can do is uh, we can find, like, we can generate all the possible subarrays and try to find the number of occurrences uh, of k in that and compare with the number of occurrences with the every other element other than k. If the maximum of the any other element is like less than the number of occurrences of k, then we will get that array. But that uh, the time complexity for that process will be huge. Like big of will come in the order of somewhere like nc2 will be the number of subarrays, and in that we have to iterate one more time. So maybe n cube would be there. But here, as we can see the constraints, uh, in the constraints it is given that for supposing one test case, then n is max to like 100, so n cube will be like 10k powers. But if the test case, for example, 1000 will be the 1000 times 10k power, like the in the worst case, in the worst case, t is equal to 1000, n is equal to 100. So time complexity is equal to 1000 times 10 cube, which will be 6, 10k power 9, which will not will give the optimal result, because 10k power 7 executions would take 1 second, so it will take around between 10 to 100 seconds. So let me show you one very simple observation in this question, which is that mm, we can we can all, if that k element is present, then and if we take the smallest subarray uh, whose size is 1 and which contain that element uh, k itself, then uh, that one size subarray uh, in that one size subarray, k will be present one time, and every other element will be present other than k will be present 0 time. So we will always get one sub array if that element is present in the sub array, if the k is present in the sub array. For example, in this case, k is equal to first test case, the k is equal to 4. uh, the k is equal to 4. So if we take like this, so if we take so if we take this subarray or this subarray, then we can see that in this subarray 4 is present one time and every other element is present 0 time. So our condition of k happening more than any other element is satisfying good, holding good. And same in the subarray from 3 to 3, the index from 3 to 3. So so the solution for the overall problem is that we will simply check in the array if like 4 is present in the array or not using linear. Let's now return to the problem B. So here you can see in the problem description, uh, Aleksa and Slack. So what this problem says that so Vasilije gave Aleksa a positive integer n which is greater than equal to 3 and asked him to construct a strictly increasing array of size n of positive integers such that 3 times ai plus 2 is not divisible by ai plus 1 for each i, and I ranges between 1 and n minus 2 inclusive. So here you can see the test case is between 1 and 10 to the power 4, and n which is the size of the array ranges between 3 and 2 into 10 to the power 5. Uh, so and the foundation for the positive integer should be 1 and 10 to the power 9. So you have to basically return construct such array uh, which holds thus conditions, this particular conditions. Okay, so let me explain you through my editor. So basically let me so let's take test case 1 hashtag 1. So in this let's take test case number 1 as n is equal to 3. So basically like we have to construct an integer like integer array. We have to construct an integer array of size n, right? So in this case it is 3, such that like this, consider this as a3 a2 a1. This particular condition should hold good, that is 3 times a3 modulus a1 plus a2 should not be equal to 0. We will be generating uh, some general sequence and proving whether such general sequence holds good or not for arithmetic sequence with a common difference as d, with common difference as a constant d. So for generating such thing, let's take ai plus 2 is equal to x, and let's take first common difference is equal to 1, then ai plus 1 will be equal to x minus 1. Since this is a positive difference, d is equal to 1, and we are taking positive difference because the it is given in the constant that it should be strictly increasing sequence. So ai would be x minus 2. So we have to hold good this condition. Should not be equal to 0, which is 3x modulus 2x minus 3 should not be equal to 0. So for this 3x modulus something to not be equal to 0, uh, So if this 2x minus 3 will come in the range of 1.5x and 3 should be less than 3x, then this will not hold true, because suppose this 3x, so if you divide 3x by 1.5x, then the result will be 2. But if we increase this denominator beyond 1.5x, then and keep it not equal to 3x, then this will not be uh, divisible, right? So this particular denominator, if we keep it between 1.5x and 3x, then any number between 1.5x and 3x will not be divisible by 3x, right? So we will take this particular logic and see uh, like where should we start the sequence. So if we solve this inequality, so let me solve this. 2x minus 3 should be greater than 1.5x, which implies like 0.5x should be greater than 3, x should be greater than 3 by 0.5, x should be greater than 30 by 5, which implies x should be greater than 6, right? And the other condition, the other inequality and 2x minus 3 should be less than 3x, x should be greater than minus 3, and in the condition it is also given that first the first integer should be like the in the array the first x0 should be greater than, like if you should start from greater than equal to 3. So basically we can see that if we uh, if we add these two conditions, we will get x greater than 6. So if we take the minimum value of ai plus 2 as x greater than 6, which is 7, and this particular condition, so if we take, so this is the minimum ai plus 2 value, right, which is a3. So if we start this from 7, and we can start this a3 value from 7 and can go anywhere beyond 7. And if we keep it, like since this is a arithmetic sequence with a common with a constant common difference as 1, so here we will take 6, here we will take 5, here we will take 8. So this will hold good. Okay, so now I will be showing you some the whether this particular logic get accepted in the code forces or not. So as you can see, this problem I have solved. So in this you can see that I have started the element from 5, because I have taken a3 as 7, so I have to start from 5. So here 5 is the constant, and as j increases from 0 to n minus 1, the value will also increases with a step value of 1. So here is my solution. Now I will be showing you that we can generate such a desired array as asked by this question by generating any such arithmetic sequence with a constant common difference d. Uh, so supposing supposing d is greater than 0, ai plus 2 is equal to x.
since it's increasing AP AI plus 1 will be x minus d, AI will be x minus 2d. Now we have to satisfy the condition 3 times AI plus 2 modulus AI plus 1 plus AI should not be equal to 0. For this to hold good, that is 3x modulus 2x minus 3d should not be equal to 0. This will hold good only this particular condition will be satisfied if the denominator here, which is 2x minus 3d, should be between 1.5x and 3x, because then this division will not give any positive integer. So 2x minus 3d should be greater than 1.5x and it should be less than 3x. So solving this inequation, uh, so here will be 0.5x should be greater than 3d and right side 2x should be greater than minus 3d. X should be greater than 30 by 5d, which is x should be greater than 60 and x should be greater than minus 3 by 2d. So ending both this condition, we will get x should be greater than 60. So as we saw that for d is equal to 1, we should have x greater than 6 times 1, which is 6. But for like for d is equal to 2, we will be getting x should be greater than 12. That means the minimum value of ai plus 1, which is a3, should be 13. Okay, so if we like if we wish to take this particular arithmetic progression series with common difference as 2, then we should take minimum value of ai plus 2, that is a3, to be uh, 13. Okay, so this particular thing 13, since here the common difference is 2, here I will be taking 9 and here I will be taking here I will be taking 11, taking 9, and then here I will be taking 15. And if we will move like this, then this particular arithmetic progression series with 2 as constant and minimum value of a3 to be 13 will also hold good. So let me show you my already executed code for this. So as you can see, I am starting the value from 9, since for j is equal to 0, 9 will be first, a1 will be 9, and then I am increasing with a positive step value of 2. So it will be like this. So this is here I am generating an arithmetic progression series with a positive common difference, as you can see, 9 plus j times 2. So so you can like understand that you can take any common difference uh, uh, and generate your own x here, which is a3, and accordingly we can set the arithmetic sequence. And I will be also be showing you that if we try to take like see here we got for d is equal to 1, we will get the minimum value of a3, which is we got here the minimum value of a3 is 7. If I will be showing you that, so here the minimum value of a3 is 7. For minimum value of a3 we are getting the minimum value of a1 as 5. But uh, if I try to take here 4, if I start from 4 and then move on, then this will not work. I will be showing you here as so here I will be showing if I try to execute. So if I start from, for example, 4 and then submit it, then you will be seeing some problem. See, you can see that the wrong test case on 1, since we got here the condition for d is equal to 1 as it we should have started at least with value 5. If we started with 4, so we did not get correct output. So here is the solution for my b problem. So now let's move to the question C, which is Vasilije in Cacak. Eka and Milovian, two fellow competitive programmers, decided to give Vasilije a problem to test his skills. Vasilije is given three positive integers n, k, and x, and he has to determine if he can choose k distinct integers between 1 and n such that their sum is equal to x. So this is the problem. So we are basically given three integers, positive integers n, k, and x, and so here we have to determine whether we can choose uh, k distinct integers between 1 to n such that the sum of those chosen k integers is equal to the given value x. And here test case t is given t is between 1 to 10 to the power 4, and n is the range of n is between 1 and 2 into 10 to the power 5, k is between 1 and n, and x is between 1 and 4 into 10 to the power 10. So just we have to return yes or no. If it's possible, then yes. If it's not, then no. So I'm going to show you how to solve this problem in my test editor. This problem. So suppose like so here the way I have solved this problem is uh, I have just so here n, k, x is given, and k positive integers between 1 to n such that their sum is uh, like x. So, so I will be showing you what are the range of the possible values we can generate between 1 to n. Uh, so since we have to generate k positive integers, the minimum I will show you what is the minimum possible value we can generate. So value, okay, so value will be minimum if we take 1, 2, 3 up to k, and the value will be maximum if we choose n, n minus 1, n minus 2 up to n minus k minus 1. Since we have to choose only k distinct integers, We cannot choose the same number. That's why I've chosen different numbers. So if I try to find the sum of this, that sum of from 1 to k is k plus 1 by 2, since this is an arithmetic series with 1 as a common difference, and the sum of first k natural numbers is k into k plus 1 by 2, and here the number will be k times n minus k minus 1 k by 2. Okay, so kn is k times and then minus k minus 1 times arithmetic sequence up to 1 to k minus 1. So that's why kn minus k minus 1 times k by 2. So if I show you that the sum of the possible value which we can generate is between this and this, uh, then we can like check if x lies between the set of all the possible values which we can generate, then our output is yes. If it does not lie in the set of values which we can generate, then it will be false. So if I am going to prove you that all the possible values which we can generate by taking k positive integers between 1 to k is between this two range, which is k to k plus 1 by 2 and kn minus k minus 1 times k by 2. I'm going to show that. So the way I'm going to show you is that if I increase this k to k plus 1 and keep it to uh, n, if you keep increasing this k and keep and extend it to maximum value n, then at each increment we will get uh, the sum of the values will get incremented by 1. Similarly, for this k minus 1, if we will keep increasing from k minus 1 to k, then extend it to like n minus 1, then at each step we are just increasing the overall sum value as 1. So in this way, from this state to this maximum value state, we can reach step by step with a step value of 1. I hope you are getting it. So basically, I, so this is how we have just proven that the values will, the sum of the values of k distinct positive integers will lie between this range and this range. This is sum of k distinct positive integers chosen between 1 and n. So, so I have shown you that the value, the sum of k distinct positive integers chosen between 1 and n will be lie between this and this. Okay, this and this sum. So since the reason for this is that we will, if we keep incrementing the maximum value which we have chosen among this set 1 to k and keep it to the rightmost maximum state, then at each step we are just incrementing the value by 1. So here we are basically covering all the possible values, integer possible values which lies between uh, k into k plus 1 by 2 and kn minus k minus 1 times k by 2. I hope you would have got this. So what we have to do is the sum of the values lies between these two, minimum and maximum. If we check that x lies between k times k plus 1 by 2 and kn minus k minus 1 times kn k by 2, then we have then uh, that knx set is possible. If it's not, if it does not lie this between these two values, then for this nk, x is not possible. So I'm going to show you the code which I have executed and which run perfectly. So if you see my submission here, what I did is, So you can see here A is the minimum possible value, which is k into k plus 1 by 2, and B is the maximum value, which is k times n. And if I just check the condition if x lies between A and B, which is minimum and maximum sum possible, and I accordingly output the yes and no. So hope you would have liked this my solution, and this is all for this particular contest, which is Codeforces Round 900 Div 3 problem C. Thanks for watching, and subscribe my channel for further such video explanation.